Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 3. 2-point charges are placed along the x-axis as shown in the figure. Along the line joining the two charges, how many points are possible at which the total potential due to the charges is 0, and we need to find the probable locations as well. So there are two charges, minus q and plus 2q, and they are present along the x-axis. We need to find a point at which the electric potential due to these two charges is 0. So let me just name the distance between the two charges as x. And now, one probable location can be between the charges. So let point P is the point between minus q and plus 2q at which electric potential is 0. So this is my point P, and this point P, say it is at a distance d from minus q charge. So from plus 2q charge, it will be x minus d distance. Now, electric potential at P due to minus q charge, so that can be calculated as V P A. So let me call this point as A and this point as B. So electric potential at P due to charge present at A, it is minus KQ divided by D. And this is equation number 1. Also, we can find out electric potential at P due to plus QQ charge. And that can be written as V at P due to charge present at B, VPB, that is K2Q divided by X minus D. And this is equation number 2. Now we want that at point P, the electric potential should be 0. So, according to question, Vp, that is the sum of electric potential at this point because of both the charges, has to be 0. So Vp can be written as Vpa plus Vpb. Electric potential at P due to charge present at A plus electric potential at P due to charge present at B. And that is equal to 0. So I can write minus KQ upon D plus K2Q upon X minus D is equal to 0. This minus sign will become plus when it moves towards that side. So I can write KQ by D is equal to K times 2Q by X minus D. K gets cancelled out with K, Q gets cancelled out with Q, and I am left with X minus D is equal to 2D, and this implies X is equal to 3D and D is equal to X by 3. So the first location, that is between the 2-point charges, it is X by 3, that is nearer to minus Q charge, somewhat over here. Now the second location, for that we need to redraw the diagram and then solve it out. So let's take the second location. Here we can see that this is a charge which is twice in magnitude as compared to the minus Q charge. So if we will be taking the point somewhat towards the plus 2Q charge, there will not be a point at which the electric potential will be 0 because the effect of this charge will always be higher and the minus Q potential can never cancel it. So the point at which the electric potential has to be 0 must be somewhat towards the minus Q charge. So let me take it as at this point. Say for example, this point is Q and it is lying at a distance A from the minus Q charge. And we have taken the distance between the two charges as to be x only. So from the plus 2q charge, q point is at x plus a distance. Now again, we need to find the electric potential at q. So electric potential V q due to minus q charge, that is charge present at A. So it can be written as minus kq divided by A. And electric potential at q due to charge present at B, that is VQB, it is k times 2q divided by x plus A. And we want that at point q, the electric potential has to be 0. So VQ is equal to electric potential at q due to charge present at A plus electric potential at q due to charge present at B, that has to be 0. So equate VQ is equal to 0 and VQA is minus KQ divided by A plus K times 2Q divided by X plus A. I can reshuffle the equation in order to find the value of A. So this implies KQ by A is equal to K 2Q divided by X plus A. K gets cancelled with K, Q gets cancelled with Q, and I am left with 2A is equal to X plus A. And this gives me X is equal to A or A is equal to X. So from a distance that is between the distance, that is the distance between these two charges towards the minus q charge, the electric potential will be 0. So these are the two possible points. One is between the charges and other one is on the line joining the two charges towards the minus q charge, at which the electric potential is 0. And this is the answer for this question. Keep learning, keep practicing, keep excelling.